everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a given differential equation which is non-homogeneous. So let's get going. Problem: solve x plus y minus 1 into dy by dx equals to x minus y plus 2. Solution: given differential equation, x plus y minus 1 into dy by dx equals to x minus y plus 2. Now take these two RHS, will get dy by dx equals to x minus y plus 2 by x plus y minus 1, which is in dy by dx equals to a1x plus b1y plus c1 by a2x plus b2y plus c2 form. Right. So here compare these two. By comparing these two, we'll get a1 b1 c1 a2 b2 c2. Okay. If you consider the numerator, quotient of x will be your a1 and quotient of y will be your b1 and c1 will be the constant. And now compare the denominator. Quotient of x will be a2, quotient of y will be b2, and you'll get one constant. Okay. So, and also this of dy by dx equals to some function of xy form. Right. So you can consider f of xy as, or let f of xy equals to this function of x and y. X minus y plus 2 by x plus y minus 1. If f of kx ky equals to f of xy, then we can say that this function is homogeneous. If this function is homogeneous, then we call the differential equation involving homogeneous function as homogeneous differential equation. So let's see whether function of kx ky equals to function of xy or not. Okay. Simply replace x by kx and y by ky in f of xy, then we'll get kx minus ky plus 2 by kx plus ky minus 1, which is equals to, here we cannot take k common from all these three terms, and in the denominator also we cannot take k common from all these three terms. So from this we can say that since you are having constants, okay, if you don't have these constants, then simply you can take k common and you can cancel k from numerator and the denominator, then we'll get function of x, y in some cases. But in this case, we are having constants, so we can say that f of kx ky is not equals to function of xy. See, function of xy does not involve any k, right? So the given function is non-homogeneous, or by looking at the differential equation, you're having a constant here and here, right? So from this we can say that the given differential equation is non-homogeneous. Fine. Since the given differential equation is non-homogeneous, so which is in this form and it is non-homogeneous. Now by comparing these two, write a1 b1 c1 a2 b2 c2, where a1 equals to quotient of x in the numerator 1, b1 equals to quotient of y in the numerator minus 1, and c1 equals to constant in the numerator 2, and a2 equals to quotient of x in the denominator 1, and b1 equals to quotient of, b2 equals to quotient of y in the denominator 1, and c2 is the constant existing in denominator minus 1. Okay. Now find a1 b2 minus a2 b1 equals to a1 1 into b2 1 minus a2 1 b1 minus 1, which is equals to 1, minus into minus plus 1 equals to 2, which is not equals to 0. Therefore, a1 b2 minus a2 b1 equals to 2, which is not equals to 0, or you can say a1 b2 minus a2 b1 is not equals to 0. Consider the given equation or this equation as equation 1. Okay. Since a1 b2 minus a2 b1 is not equals to 0, now put x equals to capital X plus h and y equals to capital Y plus k in equation 1. Okay. So you're having x equals to capital X plus h, right? If you differentiate on both sides with respect to x, you'll get dy dx of x equals to dy dx of capital X plus h. Then you'll get derivative of x with respect to x is 1 equals to derivative of x with respect to x plus derivative of a constant with respect to x is 0. Then you'll get 1 equals to dx by dx. Then that is differential of capital X by differential of small x. Then you can write it as 1 into dx is dx equals to capital dx, right? Also, you're having y, small y equals to capital Y plus k. If you differentiate on both sides with respect to y, the small y, then you'll get derivative of small y with respect to small y is 1 equals to derivative of capital Y with respect to small y plus derivative of a constant with respect to small y is 0. Then you'll get 1 equals to dy, that is d, differential capital Y by differential small y. So from this we'll get 1 into dy small dy equals to d capital Y, right? Since we are having small, that is differential small x equals to differential capital X and differential small y equals to differential capital Y, then you can write dy, this differential dy by dx as dy by dx. Okay. Now put x equals to capital X plus h and y equals to capital Y plus k and this one in 1. Then 1 becomes, replace dy by dx by this, you'll get d capital Y by d capital X equals to, replace x by capital X plus h minus y, replace small y by capital Y plus k plus constant by, again replace x and y here, you'll get capital X plus h plus capital Y plus k minus 1. Then you can write this as dy by dx equals to capital X plus h minus y minus into plus minus k plus 2 by capital X plus h plus y plus k minus 1. Then dy by dx equals to, write x and y terms first, x minus y plus the remaining terms h minus k plus constant by x plus y plus h plus k minus 1, which is in dy by dx equals to a1x plus b1y we have dy by dx equals to x minus y plus h minus k plus 2y x plus y plus h plus k minus 1, right? Which is in dy by dx equals to a1x plus b1y plus a1h plus b1k plus c1 by a2x plus b2y plus a2h plus b2k plus c2 form. See, quotient of h and k, sorry, h and x is 1, right? The quotient of x and h is 1, a1, right? a1 is 1. Now, quotient of y and k is b1. What is b1? You are having minus 1. See, quotient of y and k is minus 1, and you have c1 in the numerator, which is 2. Likewise, compare the denominator. Quotient of x and h is a2. a2 is 1. Quotient of x and h is 1, and quotient of y and k in the denominator is b2. b2 is 1. You are having 1, right? And likewise, you have c2 equals to minus 1, right? Fine. Since this equation is in this form, so what we'll do is we'll choose h and k such that this polynomial becomes 0. Okay, choose h and k values such that this polynomial h minus k plus 2 equals to 0 and h plus k minus 1 equals to 0. If this becomes 0, you'll get x minus y by x plus y, so that this equation becomes homogeneous, and then we can say the given equation is reduced to a homogeneous equation. Okay, if this one and this one becomes 0, then we'll get a homogeneous equation. Okay, so let's see. So how to find h and k such that this equations becomes 0, this polynomials becomes 0. So by solving these two equations, we'll get h and k values. See, h minus k plus 2 equals to 0, h plus k minus 1 equals to 0. Now we can cancel minus k and plus k, then you'll get h plus h. 2h plus 2 minus 1 is plus 1 equals to 0. Then 2h equals to minus 1, then you'll get h equals to minus 1 by 2. Therefore, h equals to minus 1 by 2, right? And if you put the value of h in any of these two equations, you'll get the value of k. So Let's take the first one and put h equals to minus 1 by 2. We'll get minus 1 by 2 minus k plus 2 equals to 0. Then minus 1 by 2 plus 2 equals to, take this minus k to RHS, it becomes plus k. Then take the LCM, you'll get minus 1 plus 2 2s are 4 by 2 equals to k. Then 4 minus 1 is 3 by 2 equals to k. So therefore k equals to 3 by 2. So now if we substitute h and k values in these equations, we have to get 0. We have to check whether these values are correct or not. Take the first one, LHS part of first one, and substitute h and k. Minus 1 by 2 minus k, for k equals to 3 by 2 plus 2 equals to, take the LCM, you'll get minus 1 minus 3 plus 2 2s are 4 in the numerator by 2. Minus 1 minus 4 minus 3 is minus 4 plus 4 by 2. Minus 4 plus 4 is 0 by 2. 0 by 2 is 0. So this equals to 0. Right? Now check the second one. Since we have to choose such h and k such that this equals to 0 and this is also equals to 0. Okay? This one becomes 0 and this one becomes 0. We have to choose such h and k. Now pick the second one, h plus k minus 1. Now put the values of h and k. Take the LCM. In the numerator you'll get minus 1 plus 3 minus 1 into 2 is minus 2. This equals to 3. Minus 1 minus 2 is minus 3 by 2. 3 minus 3 is 0 by 2. 0 by 2 is 0. So this equals to 0. Right? So our values of h and k are correct. And by substituting h and k, we'll get this polynomials 0. Okay? Fine. Therefore, h equals to minus 1 by 2 and k equals to 3 by 2 such that one polynomial becomes 0 and other polynomial also becomes 0. Right. Now, coming to this equation, when this becomes 0, since we can give the equation numbers, okay? I forgot to give. Since h minus k plus 2 equals to 0 and h plus k minus 1 equals to 0, then 2 becomes dy by dx equals to x minus y plus, this is 0, by x plus y plus 0. Right? Then dy by dx equals to x minus y by x plus y. Consider as equation 3. Now this is in dy by dx equals to function of xy form. Right? Let f of xy, function of xy, be this function, that is x minus y by x plus y. If function of kx, ky equals to function of xy, then we can say that this function or this function is homogeneous function, and then we can call the differential equation involving homogeneous function as homogeneous differential equation. Okay. Now f of kx ky equals to replace x by kx and replace x by kx and y by ky, then you'll get kx minus ky by kx plus ky. Now take k common from the numerator and from the denominator as well. You'll get k times x minus y by k times x plus y. Here k gets cancelled. You'll get x minus y by x plus y, which is a function of xy, right? So from this we can say that therefore f of kx ky equals to f of xy. From this we can say that this function is homogeneous function, right? Therefore f of xy is homogeneous. Then the differential equation involving homogeneous function is called a homogeneous differential equation. So what we have done now, we have reduced the given non-homogeneous equation, okay, or this one, non-homogeneous differential equation to a homogeneous differential equation. Now we can proceed the homogeneous differential equation procedure to find the general solution, the method, okay, the method to solve homogeneous equation and find the general solution. Fine. So now we have reduced the given equation to homogeneous equation, right? dy by dx equals to x minus y by x plus y, right? Now what we have to do is, we'll simply follow the procedure to find the general solution to the homogeneous equation. Now let y equals to vx. If you differentiate on both sides, you'll get with respect to x, then dy by dx equals to, here apply u v whole dash formula, u dash v plus v dash u, dv by dx into x plus v into or v dash dx by dx into v, then you'll get dy by dx equals to x into dv by dx plus derivative of x with respect to x is 1 into v, then dy by dx equals to v plus x into dv by dx. Okay. Now 3 becomes replace dy by dx by this, we'll get v plus x into dv by dx equals to x minus replace y by vx, and you'll get x minus vx by x plus vx, which is equals to, now take x common from the numerator and the denominator as well. You'll get x times 1 minus v by x times 1 plus v. Here x gets cancelled and this is equals to 1 minus v by 1 plus v, right? Now you're having v plus x into dv by dx equals to 1 minus v by 1 plus v. Now take this v to RHS, it becomes x into dv by dx equals to 1 minus v by 1 plus v minus v, which is equals to 1 minus v times 1 plus v by 1 plus v, which is equals to 1 minus v. Minus v into 1 is minus v. Minus into minus, sorry, minus into plus, minus v into v is square by 1 plus v. Then we'll get x into dv by dx equals to 1 minus v is minus 2v minus v square by 1 plus v. Then x into dv by dx equals to, take minus common from all these three terms, you'll get, or simply rewrite it as minus v square minus 2v plus 1 by v plus 1. Okay. Now take minus common from all the three terms in the numerator, equals to minus of v square plus 2v minus 1 by v plus 1. Now, since you're having dv by dx, dv comes in the numerator, so what we'll do is we'll write functions of v in LHS and differential dv in LHS, and functions of x and differential dx on the other side. Okay, then this becomes v plus 1 by v square plus 2v minus 1 into differential dv equals to minus 1 by x into dx. Okay, here the variables are separable, right? Since we know that integral f dash of v by f of v into dv equals to log mod f of v plus integral constant c, right? Now, if f of v equals to the denominator polynomial which is in the denominator v square plus 2v minus 1, then f dash of v will be derivative of v with respect to v is 2v, sorry, derivative of v square with respect to v is 2v plus derivative of 2v with respect to v is 2. So we'll get f dash of v is 2v plus 2. In order to apply this formula, we need a 2 here, right? 2 times v plus 1, so that you can apply this formula. So what we'll do is we'll simply multiply and divide 2 to this. Then you'll get 2 by 2 into v plus 1 by, sorry, now perform integration. Fine. V square plus 2v minus 1 into dv, or you can multiply and divide 2 inside the integral to this integrand, equals to minus integral 1 by x into dx. Then take 1 by 2 as constant outside the integral into 2 times v plus 1 by v square plus 2v minus 1 into dv equals to integral minus integral 1 by x dx, right? Then 1 by 2 integral 2v plus 2 by v square plus 2v minus 1 into dv equals to minus integral 1 by x dx, which is in f dash of v by f of v dv form. So now we can apply this formula. Then this becomes 1 by 2 into log mod f of v, that is log mod v square plus 2v minus 1 equals to minus integral 1 by x dx is log mod x, plus, since both the terms are in log, so we'll write integral constant as log c. You can write this as 1 by 2 into log v square plus 2v minus 1 equals to minus log x plus log c. Now, take this 2 to RHS, it becomes log v square plus 2v minus 1 equals to 2 times minus log x plus log c, which is equals to minus 2 log x plus 2 log c. Since we know that m log n can be written as log n power m, then you can write log v square plus 2v minus 1 equals to m log n as log n power m plus log plus again m log n as log m power n c square, right? Since we know that log a plus log b equals to log ab, or firstly you can write c square as c, since c being constant, then this becomes log v square plus 2v minus 1 equals to log x power minus 2 plus log c. Since c square being constant, we'll write c square as c. Right? Now apply this here, we'll get log v square plus 2v minus 1 equals to log ab. Since we know that if log a equals to log b, then a equals to b. Then this becomes log a. Since log a equals to log b, then a equals to b. Okay? Then v square plus 2v minus 1 equals to, we know that x power minus n equals to 1 by x power n, then you can write this as c by x square. Okay? Now, we are having y equals to vx, right? From this we'll get v equals to y by x. Now replace v by y by x. Now put v equals to y by x. You'll get y by x whole square plus 2 times y by x minus 1 equals to c by x square. Then this becomes y by x whole square is y square by x square plus 2y by x minus 1 equals to c by x square. Now we'll take LCM from LHS. LCM of x square, x and 1 is x square. X into x is x square, x1s are x1, x into x square, right? In the numerator you get y square plus 2xy minus x square by x square equals to c by x square. X square in both the denominators gets cancelled and you'll get y square plus 2xy minus x square equals to c. Now what we have to do is, we'll replace capital Y in terms of small y and capital X in terms of small x using x, y h and k. Since you're having small x equals to capital X and plus h, now replace, put h equals to minus 1 by 2, then you'll get, take this minus 1 by 2 to LHS, you'll get x plus 1 by 2 equals to capital X. Okay, therefore, capital X equals to x plus 1 by 2. And now consider y equals to capital Y plus k, and put k equals to 3 by 2. Then you'll get y equals to capital Y plus 3 by 2. You can just write this as y plus 3 by 2 equals to small y. From this you'll get y, capital Y equals to small y minus 3 by 2. Therefore y, capital Y equals to small y minus 3 by 2. Okay. Since capital X equals to this one and capital X equals to small x plus 1 by 2 and capital Y equals to small y minus 3 by 2. Now we can replace this using these two. Okay. You can name it as equation number 4. Okay. Put capital X equals to small x plus 1 by 2 and small y equals to, capital Y equals to small y minus 3 by 2 in 4. Now 4 becomes y square, that is small y minus 3 by 2 whole square plus 2xy into y minus x square equals to C will be the required general solution. Okay. Therefore, the required general solution is y minus 3 by 2 whole square plus 2 times x plus 1 by 2 into y minus 3 by 2 minus x plus 1 by 2 whole square equals to C. So this completes the problem. So we have seen a problem from a non-homogeneous equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.